Question 13 is about the Newton-Raphson method. The Newton-Raphson formula is in the formula book. It says the next n plus 1 is equal to xn minus f of x over f dashed of x. Now, f of x we've been given. F of x in the question is x cubed plus x squared minus x plus 5, and they should all have n's on them. So when we differentiate that, we're going to get 3x squared plus 2x minus 1, and again I should have n's in each of those. There's a bit of tidying up to do to make this look how they want it, and so I'm going to times that up there. I'm going to get 3x cubed plus 2x squared minus x minus all of this, x cubed plus x squared minus x plus 5, all over 3x squared plus 2x minus 1. Sorry, there's so much to write here, isn't there? So tidying all of that up, we've got a total of 2x cubes. I'll add the n in this time. This, take away this, is just the 1xn squared. That minus that is 0, actually, isn't it? And then we've got minus 5 all over 3xn squared plus 2xn minus 1. So there's the iterative formula. For part B, you're then told to throw in x1 equals minus 2. And we're going to try and figure out. So put the minus 2 in there, tap all of that into the calculator, and you get minus 2.4286 to 4 decimal places. And I'll trust you can tap that one into the calculator as well to get minus 2.3443, and the fourth one 2.3403. In the next part, you're asked to show that the answer is actually 2.403 to 4 decimal places. So we'll put f of x going all the way back to the beginning again, which was the x cubed plus x squared minus x plus 5. And what we're going to do is we're going to think, what is this as low as it could be? So we'll go for 035, and we'll tap that one in. And then the other side of it would be 3025, the other side of that. Well, this one here is greater than 0. You can figure it out, it's very tiny. And this one here is less than 0. So we can then write the words change of sign and f of x continuous. Therefore, alpha is this. I won't write it all out again, to 4 decimal places. Nice part D. What happens at x equals minus 1? Well, at x equals minus 1, if you go all the way up to the top there again, this was the derivative. F dashed of minus 1 equals 0. And that means it's a stationary point. And in the Newton-Raphson formula, that means when you do the tangent would never meet the x-axis. And so you'd never get a second approximation. Of course, it does mean you're putting 0 at the bottom of the fraction, so you can't divide by 0, but this is fundamentally why the Newton-Raphson doesn't work.